learn some basic concepts about photoelectric effect. You know that light has dual nature. That is, light sometimes exhibits wave-like property and sometimes exhibits particle-like property. Here in this topic, you will see that the particle property of light is entirely responsible for an effect called photoelectric effect. So let's start our discussion. In photoelectric effect, it is found that whenever light falls on a metal surface, then this metal surface ejects some electrons. Now these electrons, which are emitted by this metal surface when light falls on it, are known as photoelectrons. And the whole process is known as photoelectric effect. And this emission of electrons is known as photoemission. Now let us understand why this happens, how this metal plate ejects electrons. Here you need to understand that you need to know that light consists of small energetic particles called photons. So photons are nothing but small energetic particles which are associated with light. So if I draw some photons, so here light is falling on the metal surface. So you have to imagine that light consists of small particles called photons. So these are the photons which I have drawn. Now each photon has energy E equals to h nu, where nu stands for the frequency, and also it can be written as h c by lambda. C stands for the frequency, c speed of light, lambda is the wavelength. Now in this photoelectric effect, you will see that it is entirely one photon, one electron phenomena. So it is one photon, one electron phenomenon, which means that each photon has energy given by E equals to h nu or hc by lambda. Now this photon has certain energy, and that energy is quickly absorbed by this metal plate, and this metal plate in return emits one electron. And the mechanism is that if this metal plate absorbs the energy of one photon, as it is written here, I repeat, if this metal surface absorbs the energy of one photon, then this metal surface will give you only one electron. It will never happen that this metal surface will absorb the energy of one photon and in return it will give you two photons. It is not possible. So it is a one photon, one electron phenomena. So you have to remember this. Now the question arises that can any photon eject electrons from a metal surface? Answer is no. It is found that every photon must have a particular frequency or lowest value of frequency. We call it as threshold frequency. So there exists a minimum value of frequency called threshold frequency, which each photon should have, so that this metal surface can emit photoelectrons. So we define a term called threshold frequency. And threshold frequency is denoted by symbol. Frequency is nu and we give a naught, mu naught. So threshold frequency is one term which is very closely associated with photoelectric effect. So threshold frequency is the minimum frequency of the incident photons so that this metal surface is able to eject photoelectrons. Now we defined a term called work function. Or sometimes we say photoelectric work function. Now what is photoelectric work function? Let us understand. Suppose I take one photon whose frequency is just equal to the threshold frequency, and you know that the frequency of any photon having frequency nu, the energy is given by this formula. So this is the energy associated with any photon having frequency nu. But my aim is to find what is the energy associated with a photon whose frequency is just equal to the threshold frequency. So what I get is, if I use this formula, now the frequency associated with the photon is just equal to the threshold frequency. So this nu has to be written as nu naught, threshold frequency, and h is Planck's constant, h. Now it is equal sign, equal sign. So this is the energy associated with a photon whose frequency is just equal to the threshold frequency. And here, instead of E, we use a symbol called phi naught. And that itself is the formula to calculate work function or photoelectric work function. Now this is normally in joules. But sometimes we calculate this work function in another unit called electron volt. The conversion is, as given earlier, 1 electron volt is 1.6 into 10 to the power minus 19 joules. So work function is calculated in joules, or you may calculate in electron volt. Now let us define what is work function. So you can define work function in different ways. The first definition of work function is that work function is the energy associated with a photon whose frequency is just equal to the threshold frequency. But in other way, we also define work function as the minimum energy of incident photons. I repeat, it is the minimum energy of incident photons which is responsible for emission of photoelectrons from any metal surface. Or in other words, you can say that it is the minimum energy of incident light required to exhibit photoelectric effect. So these are the three different ways to define work function of a metal. Please remember that every metal has got different values of work function. Example, if I take maybe one metal A and if I take another metal B, this metal A has a work function 2.2 eV and this metal B has a work function 3.1 eV. So if this is known, then what do we understand from this? Metal A has a work function of 2.2 eV, which means that the metal A is going to emit photoelectrons if the light which is falling on the metal surface has minimum energy of 2.2 electron volt. If the light which is falling on the metal plate A has energy less than 2.2 eV, it will not emit any photoelectrons. Similarly, metal B has a work function of 3.1 eV, which means that metal B is going to emit photoelectrons if the light which is falling on the metal surface has a minimum energy of 3.1 eV. If the light which is falling on the metal surface B has energy less than 3.1 eV, then this metal plate is not going to emit any photoelectrons. So, work function of a metal varies from metal to metal, and work function simply helps us to understand what is the minimum energy of incident light required so that this plate is able to emit photoelectrons. How to increase the number of photoelectrons emitted in the process of photoemission? So our aim is to understand how to increase the number of electrons being emitted. Now, as you know that it is a one photon, one electron phenomenon. That means this plate will emit one electron if it absorbs one photon, energy of one photon. So somehow if you can increase the number of photons falling on the metal plate, then definitely we can increase the number of electrons which are emitted from this metal surface. And one way to increase the number of photons falling on the metal surface is to increase the intensity of light. So here we define a term called intensity of light. Intensity of light is nothing but amount of light. So intensity is a technical term. So normally you can say that if you are increasing intensity means you are increasing the brightness of light. Increasing the brightness means you are allowing more and more light to fall. So simply if you allow more and more light to fall on the metal surface, technically you are increasing the intensity of light. So what will happen if I increase more light to fall on the metal surface? See, more intensity actually means more light. And you know that light consists of energetic particles called photons, and more light means more number of photons, and more number of photons means more number of photoelectrons, and hence more number of photoelectrons. So that is one way to increase the intensity, one way to increase the photoelectrons. That is, if you increase the brightness of the light which is falling on the metal surface, then you can increase the quantity of photoelectrons.